Hi everyone, and today is a very interesting session. Today I'm inspired by this project called Claude Plays Pokemon, where someone used Claude, interface it with Claude's vision model to interpret the game state of Pokemon Red, right? And then use the thinking model to do some thinking as to where this person is going to. So basically, given the screen, given the RAM state of the game, whereby, they get the Pokemon kind of characteristics, the map position, and so on, the model will think and then do certain actions, either navigate to a certain spot in the map or to update its knowledge base. And then it can also retrieve its knowledge base to augment the context to choose better actions. So right now it's progressing not too bad. It's now at Cerulean City, which is like the third city in the game. It occasionally gets confused and goes in loops. Actually, not occasionally, very often it will get confused. So there's certainly something going on with memory, and how to use memory to remember past context is of absolute importance to solving this kind of game worlds and even in real life. So what I realized after watching this for one over a week is that the memory really defines how an agent behaves. Because if you don't give it the right memory, it would keep thinking that it has explored the same area, and that area might be new to it. Like, so it keeps exploring the same area, but it keeps thinking, hey, it's something new, it's something new. So yeah, just to share also, like, I'm also creating my own project with a group of people, like mainly Dylan and Nicholas. And basically this is what we will do. Like, we will just interface it with some straight JSON with LM parser that I've created. Now I've made it multimodal. So basically we can key in images using these angle brackets. So for example, now we are using Gemini 2.0 Flash. Okay, we can run the game by uploading it on a Flask app, and then we just query the game. And basically, I just do a very simple loop, like based on the image and game state, make a decision of what to do next, and give it some idea of what are the different actions it can do, and then ask it to describe what it's doing, describe the state, what to do next, and choose the next action. Okay, and then we update the context. So this is very, very basic. I haven't really done much memory manipulation yet. That will be for future research. And what I hope is that it would do better than Claude Plays Pokemon. So need to think about what kind of memory structures are there, how to make the agent think better and not forget what it has remembered, what it has seen before, and how to extract thoughts and reflections and all this. This is very, very important for an adaptable agent. Right, so you can see that we just give the image in angle brackets like that, just like that. The backend code is all settled to interpret the image. So let's just run this and we see what happens. So this was the previous one. The player has entered the building. I should go up and enter the building. So this is the picture and the updated context is this. So if we run this again, we can see what's going on. And yeah, so now it's standing in front of the building. It should enter the building, press A. Okay, this actually cannot enter already because once you leave, I think they block you from entering again. So what we need to do is we need to explore the map further. Yeah, I haven't really coded in more of the stuff, but you can see it's trying to enter the building now. So this is the current progress of the game. And yeah, I'm going to go to the slides and start the session today proper. Let me go to my slides. Okay, can you all see the screen? Just give me a thumbs up if you can. All right, so today we'll be talking about the insights that I've gained from watching the Claude Plays Pokemon stream, as well as like how it works and how I think it could be better improved. At any point of time, feel free to chime in with your views as well, because I think this is an area that is quite interesting. If we can solve games like this, we can also extrapolate it with better vision models to the real world, and then we have a adaptable agent in the real world as well. It could eventually even be put into robots and so on. So I would say that this game world is not just a game. It's actually an interactive world with feedback loops. And this is quite important to advance the state of the art in agentic research. This game, Pokemon, is useful because it is not real time. So, LLMs take quite some time to think, to get the output out. If we do this in a game world like this, it gives more time for the LLM to decide the action. Once the LLM can do it in near instant processing, like you can process 1 million tokens in less than 1 second. That could happen in 1 to 2 years' time. Then we can proceed to play it on real life games like first-person shooters and so on. So this one is something quite interesting. And let's just take a look at why Pokemon is used. All right, because recently in Claude's extended thinking model, the 3.7 Sonnet, they said that just by changing the LM, they managed to reach search batch, which is like the third batch in the game, right? Then the previous model all couldn't like pass Mount Moon. Okay, Mount Moon is quite funny. Later I'll show you why it's funny. Okay, for those watching the Claude Plays Pokemon stream, you will understand why Mount Moon is funny because everyone thought that the LM would be stuck in Mount Moon, right? So you can see that there's actually quite a breakthrough here in the sense that once we just increase the model's thinking capabilities, we seem to actually bypass using the same structure. We seem to be able to solve more things, right? Of course, my thinking is that, it's not just the LM that's important. Having the right structures to store memory, to retrieve memory is also very important. And we'll see like how I think this could be done. So let's firstly go through how Claude Plays Pokemon does its job, all right? How does it do, all right? So what it does is that it has a few things it can do. These are the tools that it has. The tools that it has this thing called the update knowledge base, which is basically, if you want to change what the agent knows, you have a function that can edit it, delete certain things, add certain things in it. Right? We also have the use emulator tool, which basically plays the game. So it can do like stuff like A, B, up, down, left, right, select, and start. These are the Game Boy options, all right? So usually up, down, left, right is to navigate the world map, to navigate menus. A is to select. The menu B is to cancel. All right, start and select usually, these are more for like the meta game menus. All right, so this not only allows you to, play the game, they also have a sort of a cheat code where you can navigate to a specific coordinate on the screen. So instead of saying that, like let's say your player is here and your output, your desired target is here, you can just specify like maybe I want to navigate to coordinates 2, 5. Okay, I don't have to say like up, 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 right, right. So yeah, I did a quick test on a few language models to see whether they can, based on certain screenshots, navigate it. And I realized that a lot of models cannot do this navigation very well with the image as input. Like Gemini 2.0 Flash is not too bad. 4 Mini doesn't really interpret the grid that well. And, this is based on, when we do the kind of image tokenization, usually people use this thing called image transformers. Not image transform. I can't remember the exact name for it, but basically it's a transformer where they take the image and split into multiple, split image into multiple mini squares and then tokenize each square. So this basically is a way to, maybe I just draw it out. Like given an image, you split up into different squares. Like the paper is called an image is worth 16 by 16 words. So you take an image, you split into squares, and then you tokenize each square here. Yeah, and this actually loses positional information. Yeah, so somehow with the way we encode our images, we don't really get very good ways of knowing where the certain position is in the overall image. That's why there's some overlay needed. I'll talk more about that later. But even with the overlay, I find that some models cannot do this navigation very well. And that's also because language models are pattern matches. They are not exactly planners. I mean, even if you are using the thinking model, it's not natural for them to do like sort of tree search, future simulation, and so on. So let me just write here. It's not natural for LMs to do tree search simulation. Yeah. So this basically says that, if we want it to do a bit more advanced stuff with some planning, maybe we need to give it the right tools to do it. And so there's this navigate tool that can help it to navigate to anywhere that is visible on that screen. So that mitigates quite a bit of the planning issues of LMs. But because it's only limited to one screen, it can get stuck in loops. Because if, let's say, the destination you want to navigate is maybe 10 screens away, maybe by the 5th screen, it forgot where it wants to go already, right? So these are some things that needs to be thought about. And that's why it's also important to have goals, okay? Because this aligns the agent over multiple timestamps, over multiple time periods. So quite interesting because like you can see the limitations of LLMs to be an agent, in the sense that it doesn't really store long context quite well. It can struggle to do certain planning. And all these are important things to know if we want to navigate the world. Like how do humans navigate the world? Like we definitely know like, hey, I want to go to school or something. Then you can think about, okay, in this meta abstraction layer, I need to go maybe to the bus stop first, get the bus, and then after that I need to maybe take a train. Yeah, so we can already plan our route in some sense. And this kind of thing is not very native to large language models because you need to give it the information for the thing for the routes. And you know, if you give it too much information, it can actually give the wrong answer. So let me just write this down here. If you give too much information to an LM, it can hallucinate. So there's quite a bit of problems here for using LMs to be agents. And you can mitigate this a lot if you use external structures to constrain what it does. Right. So that's why there's this navigate here, because if you just do native primitive up, right kind of actions, it might not navigate properly. All right. So next, there's also okay, I already talked about the update knowledge base. I talked about the use emulator, and I talk about the navigator. So these are the three main tools that the Claude Plays Pokemon has. And I think those are quite standard tools. And I mean, it's not too bad that it can navigate all the way to past Mount Moon already. Now it's at Cerulean City. So there's some merit to this architecture. Right. Any questions that you have here before I move on? Okay, let's move on. So this is the main game loop. So this is a typical like agentic structure. You define your tools. You define some system prompt to say like, hey, what are the tools used for? Or like, what is this game about? Like maybe Pokemon is a 2D grid world, and you know the player needs to catch Pokemon and basically defeat the trainers. You could give some idea of what the game is over here. Knowledge base is basically what after you play the game, you update the knowledge base so that the agent can retrieve that as context next time to make better decisions. And this is quite cool because this knowledge base is dynamically updated. So you learn as you go. I like this approach a lot because this is the very, very basis of an adaptable agent, right? And also just giving it the knowledge base may not be that great. You still need to tell it how to use the knowledge base. So the creator of Claude Plays Pokemon did not give the prompts for all this. So until now, it's still a closed source project. But don't worry, I'm trying to replicate this as an open source project with better memory handling. So watch out for this soon. So over here, we also have the conversation history. So basically, the last few actions here, last few actions are, are also given as context to agent. And this is very important because if you don't give it the last few actions and you just give it the state itself, like maybe a chess game or Go game is probably okay. But for a Pokemon game, maybe the last few actions you try to go up to open the door and you fail, maybe you need to try another exit. But if you don't give it the past few conversation history, the agent might just be stuck doing up all the time, all right? So it's quite important to give it the past history so that it knows how to error correct itself by observing whether the last few actions have been successful. So I would say that a lot of good things about agents is due to this error correction ability. It's able to know, hey, this API call failed, so I should try something else. So this is absolutely necessary, all right, this conversation. But there's a problem here, right? The game of Pokemon or most other games can last for days, all right? Okay, for me, when I played through Pokemon Red, it took me about 16 hours to complete the whole game. And, you know, in terms of game actions, I think that's 100 over 1,000 actions. You can't store all these actions in your context. It's too long. I mean, maybe next time you have a billion context model, yes, you can store this, but right now we still face issues with context length. And that's where this summarization comes in. So after you call the model, you get your tool, and then you can see whether you need to summarize, all right? So why do we need to summarize? As I said, the actions are way too long, especially, you know, if you talk about Mount Moon navigation, to navigate from the start to the end, you might need to go through, you know, 10 different screens. I mean, 10 different maps, different sections of the maps. I can't remember, is it 10 different sections, but basically it's quite a long way in, at least 100 over steps. It's definitely not a problem that's easily solvable, even by RL standards. RL usually the maze world is like 10 by 10. So Mount Moon is like 100 by 100, that kind of thing. It's quite difficult and it involves multiple floors. So like how do we navigate this long context? It's basically saying that, hey, Claude Plays Pokemon just says that if over a certain number of turns, you summarize, right? Or if it's greater than a certain length, okay, they basically use turns as a way to gauge length. And basically what they'll do is they'll insert the summary. Instead of this conversation history, they'll use the summary instead. And this basically helps to reduce the context length until, a certain number of turns later, we summarize again. Okay, so this is actually the cause of a lot of problems in Claude Plays Pokemon because you might summarize and lose important information, right? This is something that it's quite remarkable how our brain does it, right? Like we have so much information in the world, yet we don't seem to lose track of what's important. Okay, there must be a priority system that we use to store our memories. And if you just look at this summarization for Claude Plays Pokemon, a lot of times it might summarize away like facts that, hey, this letter is important. And then, you go in loops again trying to find that information. So this is something that we need to look into, how to effectively learn and store what we learn so that we can retrieve it next time. Okay, so yeah, that was a bit of technical stuff. All in all, we have a game interface to let Claude control the game. We have a screenshot analysis to look at the screenshots and interpret what's happening. All right. This screenshot analysis is likely the language model itself because you can interpret images as an LM using base64 encoding for the image. So image tokens to LM. Okay, this is not a separate image model. This is the image tokens to LM. And I would say I tested Claude 3.7. It's wonderful. It's actually much better than Gemini 2.0 Flash, much better than 4.0 Mini or 4.0 in terms of understanding the game image. So kudos to Claude for that. Yep. So this is the screenshot analysis. We do have a knowledge base where you update the things that you have learned as you experience in the game, have you gained experience in the game. We have a navigation system to help to navigate to a certain coordinate, right? I would say that this navigation system is not powerful enough. I would say that you should navigate to any text location. So it's like if let's say your game wants to go to the last Pokemon Center, I was thinking of giving a navigate function that in just free text, because LM agents are great at giving free text output. In just free text, you can just tell the navigator, hey, I want to go to maybe the last Pokemon Center. And the navigator will have access to previous memory and then find a path using some algorithm to navigate there. Okay, if we can solve the navigation problem, I think we can solve the Pokemon game. Okay, because the fights itself are quite good, right? The LM is able to identify type weaknesses, give the right moves, and in general, Pokemon fights are quite easy. All right, you can over level your Pokemon and win the game, and you literally need zero skill. So I would say that if you can solve navigation, you can solve the Pokemon game. So this is something that is absolutely critical and is missing, right? So I will probably be implementing this in my own implementation. Right, next, we have a memory reader. And this memory reader is basically getting the extra states of the game, like the RAM states that contain the location, the party information, and so on. To be honest, I think this is a little cheating. But if you want to use LMs to know where you are, you need to have some reference coordinates. So I think this is still okay. Yeah, but eventually I hope to do away with this altogether because humans just need to use the image, right? We don't have to use the RAM state. In fact, we are not given access to the RAM state when we play the game. So I think eventually I want to remove this from the architecture, but for now we can keep this. Okay, this is the overall flow of the game as you all saw in the first screen just now. What Claude will have is they will have this image. We'll have the RAM state, which is not shown here, which is basically like what are the different kinds of, maybe I can show you the RAM state from a previous image. Yeah, if you look here, this is the RAM state. It's a bit small, but what's the player's name, what's the location, what's the coordinates, what are the items that the player has. Later at the bottom, what are the Pokemon, right? So this is the RAM state. So given the RAM state plus the image, we'll do some thinking tokens. So this kind of looks like DeepSeek, right? The thinking with this. You can also do this thinking with JSON or YAML, as long as you have a way to prompt the model to think, right? Or if you use a thinking model, they will automatically have thinking tokens. All right. So this is the thinking. And then after that, they will decide, hey, what should I do? Maybe you see the earlier one, they use the emulator. There are other tools that you can use. That's why I said you can use the navigator to navigate to a certain coordinate. You can also use the knowledge base function to edit or retrieve knowledge. So this is the way that they use to give the coordinates to the LM, and actually it's quite good. I've tried this, and giving just this left image is not very good for navigation. Giving this right image is much better. Right. So what they did is basically given the RAM state, you know this person's location. Okay, then you already know each sprite contains how much width. So it's a bit of hacking for this game, but I think it's allowable because LMs are not very good with position. As I said, the image transformers are not that great with position because you split into squares, but you don't really store the position info somewhere, right? So this is the way you do it. And then you can ask the LM to say, hey, how do I navigate to this NPC? And I've tried it, it works, right? It can navigate pretty well. It knows that it needs to go here and go here. Okay, 4.0 Mini is not very good with this. It doesn't really plan very well, but Gemini 2.0 Flash, Claude 3.7 Sonnet, all okay with this kind of navigation, right? So you overlay with the coordinates, and what the person creating Claude Plays Pokemon found out is that, if you don't give certain coordinates in red, the LM might just think that, this is a grass patch and it can just go straight like that. Okay, so I don't know how they did this logic. Perhaps they identified this as a wall tile and did some algorithm to say that, hey, these squares here are not navigable. Okay, but there's a red squares, which means not navigable, and there's a yellow square, which means that it's the edge of the wall. So all these helpful cues help to let the LM know like which tiles can navigate, which tiles cannot, right? So this is something that is quite useful for an LM to use the game information to do navigation. All right, let's move on. So the updating of knowledge base is like this. What we do is that once we have certain kind of, after a certain number of turns, they update the knowledge base with like what's the inventory, what kind of knowledge to update for the battles, what the objectives. So like the goals are in this section, objectives. So you can see that, if you watch the stream, like the knowledge base update, they will show you like these are maybe the objectives. Okay. So like need to find a way to route tree, heal the Pokemon and so on. So this gives the meta context as to what actions the agent should prioritize. And I think that's really cool, like how we update this knowledge base and so on. Okay. However, as I said earlier, updating this knowledge base sometimes may not update with the right things. So like this is the initial version of Claude Plays Pokemon, the first version, keeps saying excellent progress. So basically the agent comes from this red arrow down here, and then you notice the ladder and say we should explore the ladder. After explore finish already, that's the dead end. It comes out of the ladder, and then it says that, hey, I need to explore something to the westward. All right, let me explore westwards. All right, it knows that it needs to go somewhere here, all right, but it didn't know that it came from the top, you see. So it thought that, okay, to explore west, maybe I should go up and search here first. So guess what? For 3 days, it repeated this loop. Go left, come back to this ladder, go inside here, go up, then come back here. I mean, the game actually has a whole map coming down here. So it repeated this loop again and again for 3 days. And this kind of highlights that, it doesn't really remember where it came from. So in the knowledge base, maybe it can say that, hey, I've explored this ladder before. But, it didn't really reflect which parts of the map it has explored. So if it had managed to say that, hey, I've explored the top before, now I should go down and explore, then it would solve the navigation problem already. So there's a lot of things like this that are not really reflected in the knowledge base. And if it gets stuck in the map somewhere, uh, it might actually lose the information that, it might have explored this ladder already. So it's very, very, how I'd say, it's quite difficult for the LM to remember very, very complicated maps like this. And this is just a reflection that, maybe storing everything in a knowledge base may not be the best option. You might need to have specialized modules to maybe do navigation, specialized modules to do, I don't know, battling. Yeah. So the idea that just one component can do everything, maybe that's a flaw. All right. Maybe we need to know different components to do different things. Right. So AGI says that everything is general, right? I don't think AGI is possible actually. Like I do think that you can only do the skills that you are given. Like you can't like create any skill in the world, right? So this of course is something that is not too much of a downer actually, because a lot of things that we do in our lives use the same kind of skills. So we just need to recreate that in AI. Right. Questions for this? I think this is a very, very interesting finding. It's really, really very funny to see this in real life. I don't know if you all have watched the stream, but this kind of highlights how stuff like RAG, retrieval augmented generation, how this can be problematic for agents because you might not retrieve the right information, and with the way they override the entire knowledge base, you might also lose the entire information altogether. Okay, all good. Okay, let's move on. So yeah, it keeps forgetting and forgetting, and this is a very, very interesting trend because I think with agents doing a lot more things in the world right now, like they can read PDF documents, read websites, and so on. This memory issue is going to be a huge problem because there's just too much information in the world, and there's really very limited space that you can feed the LM with, right, in terms of context. So how do we solve this memory issue? Right, is better memory structures, right? We'll talk more about this later. So you can see that if you don't give it the right memory, it would think that, hey, excellent progress, like what you saw in the previous screen. Excellent progress. Do you see this? Excellent progress. Actually, it has already explored this before, but it doesn't know. It doesn't remember, right? I mean, some people even say that Claude has Alzheimer's, but I don't want to go there because I think it's quite rude to the people who actually have that disease. So this is something that is quite crucial actually. How do we imbue the agents or the LM with the right memories so that it can last through time, right? And you can see that there's this thing called cleaning context also that makes it forget important information, and is sometimes actually the cleaning context helps because it forgets some information that is a distractor and is able to navigate out. So yeah, it was quite interesting to see how this live dynamic memory is updated. So the creator of Claude Plays Pokemon, after the first version, realized the flaw of this and tried to solve it with a new approach. And this new approach is that, hey, instead of just one memory file, I have many memory files. I have a memory file for, hey, Team Rocket. So I update everything with Team Rocket. And I can update everything with Mount Moon B2F, Basement 2 Floor. So like, for example, in the Team Rocket file, you can see that you can update based on the encounter with Team Rocket. The Pokemons that they have are like coughing and likely to encounter more Team Rockets in Mount Moon. So I think this is context-based memory. And I like it a lot because context-based memory helps you to remember more things and not override other contexts that are different. All right. So you don't really want one piece of memory that can be updated by any stimuli. You kind of want your memory to be conditioned by certain contexts. And I mean, the brain has a few ways to do this. One way to condition the memory is by location. So the context is, I'm very, very sure that the context for memory involves location because people have done studies before where they memorize words under the sea. The scuba divers memorize under the sea and at the surface, and they remember words they memorize under the sea better when they are tested under the sea. And they remember for words that they remember above the sea or on land, basically, better when they are on land. So the where we study the information or where we learn the information plays a huge role in retrieval. So maybe if you want to do well for your exams, you should study in the exam hall. Yeah. So this is something that is been proven. Location plays a huge part, and these memory files do cater for location. So I think that's a huge improvement. The other thing is emotion. Okay, so it's not really touched on in this, but you do realize that when you are sad, you recall more sad memories. Okay, when you are anxious, you recall more anxious memories. Same thing when you're happy, you can recall more happy memories. So there's this book called How Emotions Are Made. This is by Lisa Bellman Ferret, and she basically says that, an emotion is an internal body state that gets, used in terms of future recollection and so on. So this is a very important idea because we can actually do some prioritization of our memories based on certain mental states, right? You might not think that this is useful, but if you look at, like, for example, Claude Plays Pokemon, um, the game lasts for 100 over thousands of steps. You don't want to remember every single step. You kind of want to remember the key ones. And how do you remember? That's where emotions can help to play a role in terms of helping you remember stuff that are important. Like, uh, okay, I'll touch more about this. I have a slide for this. But you can see that this is the current version of Claude Plays Pokemon. The one I showed you at the start is this version. And there's still some issues. Even with separate files for each area, you still need to retrieve the right file. All right. So if you fail to retrieve the right file, you may not get the memory. All right. And you can also, overwrite stuff for that memory file if you clean the context wrongly. All right. So yeah, and also one other thing at the start, the important information may not be stored when you update the context. So again, we look at navigation. Navigation lasts through several screens usually. And what this means is that you need to retrieve information across different contexts. Like, for example, if you store Mount Moon, basement 1 floor, Mount Moon, basement 2 floor, Mount Moon, first floor, and so on. You might need to give all these things, and then you need to piece together all the kind of paths, because each floor will have different exits and entrances. You need to piece together all these paths and form a coherent path. And this is quite bad for LMs, because LMs, in general, doing this kind of very high precision planning is not the best tool to use. So maybe we need some heuristic or rule-based methods for this. Or just simply just some form of tree search methods. Yeah. So this is something that I think it's currently the weakness of LLM. Like, everyone's trying to use LLM to solve everything, like solve long chains of math, solve pathfinding, and so on. I don't think that's the right tool to use. Like, it's great to maybe point to an initial direction to explore, but it's probably not the best to do searching. All right, so some of the insights that I have for Claude Plays Pokemon. So I feel like in terms of the things that it does, all right, maybe it shouldn't just use one document for memory. Why not, store it as chunks of experiences or something that can be modified or replaced? So I highlight this paper called Generative Agents, Interactive Simulacra of Human Behavior. I like this paper a lot. In fact, this paper is still relevant even 2 years later. So you have this memory stream. You can retrieve things that are related to what you have experienced right now, the current stimuli. And then you use this to reflect. Use this to plan the action. And in fact, your plan can be stored in the stream also. And you can also use this to reflect on what has gone well and what has gone wrong. And this can go back into the stream. So I like this approach a lot because, based on what you want, you can retrieve the things needed. Of course, um, retrieval augmented generation. The downside is the embeddings may not get the right things. So maybe you need to have location first, then embeddings. You might need to store it with some index, like maybe some index, keyword index or something. Yeah, you might need to do some tricks like this to get the right memory out. And yeah, this actually is quite useful in terms of not overriding important information, because if your important information is not in conflict with what you see right now, you will never delete it. Right. So this is important, right? Because we don't want to delete away important information just because your document length is too long. All right. Sometimes this kind of not so important information might be useful in the future if you go back to that certain place again. Right. So maybe some form of memory chunks, like streams. They call it memory streams here. Basically different experiences stored in different chunks, and you just retrieve the right chunks, and you might even store back more chunks of reflection, store back more chunks of planning that can help to aid the LM or the agent better do planning next time, because you have a plan that was done before. Okay, so one thing here though, I think a lot of these papers don't really touch on this. I think this is about when to consolidate information, right? Because if you consolidate information in the middle of your task, like maybe you're navigating halfway, you haven't really navigate finished, how do you know whether your plan is successful? So, okay, I'm going to throw out this word here. So this is called the event boundary. Anyone heard of this event boundary term before? This is the hippocampus event boundary. Anyone heard of this? Okay, you are quite quiet today. I assume no? Is that okay? So yeah, feel free to let me know, okay? Because I do kind of want this to be an interactive session. So this event boundary is basically when things change a lot from the previous state. So for example, you exit your house into the street. So the moment we exit a certain place, we start to consolidate our context and store that in the hippocampus. So that's the event boundary. And this event boundary would know the overall context of what we have experienced and condense it into one chunk of memory. So apparently the brain is doing this. And I think it's quite interesting, because if you consolidate your memory earlier, okay, you might not get the full context and you might consolidate wrongly, right? And having bad memories inside here, which is like incorrectly formed memories, can actually be detrimental or bad for the entire system, because you will retrieve them next time and then you might do bad planning based on that. So how do we get this event boundary encoded? It's a very big question that I don't have the answer to. I would say one way is to just use the location that we are at, and once we leave the location, we consolidate. Yes, Derek, you want to say something?
No, I was just, you're talking about event boundaries. As I recall, doesn't surprisal play a mechanism in that psychology? Or am I recalling that wrong? Like the surprisal mechanism.
Yeah, I think if you are surprised, you will trigger the event boundary as well. I have to do some reading on that, but you are right. That could be a cause for consolidation as well. Yeah, which makes sense, because if you are surprised by something, you kind of want to figure out why you are surprised by it, like what has changed. So that could be a cause for consolidating memory as well. Okay, any other inputs from anyone? All right, let's move on. So, all right, so I want to touch a bit on emotions here, because I feel that this is what is missing right now in AI. And it's not to say that we want the LMs or the agents to anthropomorphize and be like humans. No, we don't really need that. But what we need is a way for the agents to know what information is important. And emotions are a good proxy for that, because with emotions, okay, if it's a fearful emotion, maybe I try to avoid it. And in general, our fear emotions come out quite readily when we have threats to our lives, and you remember it for life, right? Um, Case in point is like this. Imagine if you went to a restaurant and you had a tummy ache after eating it. Will you remember that restaurant for life? All right. I don't know. For me, yes. How about the rest? Do you remember, like, if you get food poisoning at a certain place, when you okay, maybe you forget the place, but once you walk by it, I'm quite sure that memory will come back. Okay. Anyone? Yeah, you all agree with that? Okay, Derek agrees. Okay. All right, let's continue. So the main thing here is there's this psychology test that people have done. Sion also said yes. Right. So there's this thing called the four deck game. So you can go and Google the Iowa gambling task. Basically, these four decks, yeah, I think two of them are good, two of them are bad, and the bad decks have really, really very negative rewards, which means you lose like $500 a kind. I can't remember the exact amounts, but the main thing in this experiment is like this. Even though we haven't really finished the entire deck, right? People know by about the 10th card or so, based on their skin conductance test, basically like they sweat a little bit more before they even reach for that deck. So at card 10, even before they are consciously aware, their sweat is already showing that they are scared of certain decks. And by the 50th card, people realize that, oh yeah, this deck has large negative reward. So you kind of already form some form of impression about the desirability of certain things even before it reaches your conscious brain. And that's largely due to some form of emotions. I don't know whether to call it emotions because it's a very loaded term. Emotions actually have a bit of cultural context embedded into it. Like the same signs of like sweaty palms might be anxious. It can be also excited. It depends on how you view it. Or like if you are in depression in the past, they call it melancholy. Melancholy, basically like it's a state whereby geniuses invent new stuff because you get so mad and crazy, you invent great art pieces or piano pieces. But in modern day, maybe you'll be admitted to a mental hospital. So it's a lot of cultural context involved, but the bodily cues are quite similar actually, like sweating, feeling increase in heartbeat rate. Yeah, those kind of things actually help to tell your body like what's good and what's bad. Like let me give you another example. Like say for example, you don't know whether to work for company A or company B. Actually, all you need to do is you just say company A's name, and then you feel your body, right? Whether is it like relaxed or a bit scared, and they say companies B, and you repeat that. Uh, your body actually can cue you to tell you what is like more desirable for you. Yeah. So even without you knowing, you can already do some form of like filtering. Yeah, it's quite interesting because our bodily states know more than our conscious minds. So a lot of times things happen, you try to find a reason to say why is it like that. Actually, it's because our body already has made a decision. You just don't know it yet. You're just trying to back reason. So it's a very loaded term to use emotions, but what I really want to mean is that we sort of form some form of impression about whether something is good or bad just by intuition or something like that. Yeah, this is an intuition that is not conscious, right? And once it becomes conscious, then you can say, hey, I feel happy, I feel scared. But you can see this ayahuasca, people actually feel scared even before knowing that they feel scared. Right? They avoid the decks that have huge negative rewards even before consciously knowing it. And yeah, quite interesting. I also read this extended mind recently, and the bodily states can really influence decisions quite a lot because this example actually came from this book. But it's not just from this book. A lot of people have cited this. David Eagleman and like other neuroscientists also cite this. I think Daniel Kahneman might have cited this before. Can't remember. But this is basically one of the key things is that your brain is not the only source of decision making, right? The brain takes inputs from all parts of your body. And that's why you don't just think with your mind. You think with, in fact, every single part of your body. Like when you do gesturing, you think with your gestures. In fact, the research has also shown that if you gesture differently from what you say, right, you won't say it well. In fact, you will find a dissonance between what you want to say and what you are doing. Yeah, so there's a lot of research that is going to show that not just rational thinking in terms of like thinking tokens maybe in text. There's a lot of thinking done that is non-verbal. Gestures, movement. People think better when they walk. Yeah, when they see new scenery. These are not really uh, highlighted in the current LM thinking tokens. All right, you don't have that because LMs are just token-based stuff. Okay. But one thing we can imbue in it, I mean, we can't really imbue walking and movement, because they are not embodied, you see. What can be imbued is like this. You can imbue a sense of what is boredom, what is scared. Like if they, let's say, Claude Plays Pokemon encounters a Zubat and the Zubat killed the entire party, you can say that Zubats are bad. Like then you try to avoid them next time. In fact, Claude Plays Pokemon actively avoids that, keeps running away from Zubats because um there was a sign that says Zubats are bloodsuckers or something that was in the start of the cave, and because of that it kept avoiding it. Yeah, so we need to make this a bit more concrete. Like when you store the experience we might want to store certain emotional states as well. That like for example, if you are bored, you might break out of a loop. Okay, because if you are bored of this area, maybe you have seen it before. Okay, there's this novelty area in the brain as well, like where you can really tell like whether or not you have done something before. And after a while, most people get bored of doing the same things over and over again. Okay, this is not the case in LM because LMs don't get bored, you see? Like they don't know what is done before and what is not. To the LM, it's just a context and they output the tokens. So we kind of need to simulate this novelty area by searching through our memory, seeing whether or not we have that kind of memory before. And if we have it, then maybe we want to do something else. So this was done quite well in RL. RL, we have explore and exploit, where we keep track of where we have explored and then try to explore something different. You might need something like this in LM-based agents. You need to tell the agent, hey, you have explored something before. Try something else, right? So this needs to be done as either an emotion or a meta structure. Okay, there are many ways to do this. I'm just talking about emotions right now because I feel like if we are able to characterize how this kind of emotions are made, or rather this like cues to the body to say that, hey, I'm scared of this, I'm very happy of this, I'm shocked, surprised. If you can store this can actually form great cues for learning, for retrieval. Of course, I still have yet to read a lot more about this. I do think this is quite important. Right? Yen LeCun also thinks it's important. If you look at some of his slides, he says that maybe emotions is the part to focus on. And he talks a lot on the amygdala, which is the fear mechanism, where basically when you store something as fear, it might actually not be a bad thing to have traumas because it helps you filter your action space to the parts that, don't get you killed. Okay. But of course, in the modern world, there's a lot of things that cause trauma and that's not that great. But if you just look at how the fundamental role of these emotions are meant to help you, it's actually meant for survival. And survival means not doing things that can get you into danger. So in this case, for like a Pokemon game, maybe if you have certain things that you are scared of, you might not cause your party to be wiped out and so on. Of course, this has a caveat because sometimes you do need to go into danger to complete the game. Like you need to fight the Elite Four at the end. So you need to balance this a bit. Okay, I don't have the answers for this. I'm just saying this out because I think this is what's lacking right now. Right. And any inputs for this? Okay, so don't worry, you have some time to think about it. Let's move on first. So I would say that once we can store certain emotions inside the memory, you can retrieve it. So retrieving it in the generative agents paper, they did by recency, importance, and relevance. So recency means how new the memory is. Newer memories are prioritized first, and that's understandable because new memories are memories that are more recent and more relevant in the world right now. Importance is based on certain kinds of emotions actually. Like the prompt they used was how poignant the memory is, scale of 0 to 10, and 10 means like something that's quite important. All right, so this importance score, and also we have a relevance score, which is basically based on this question, how relevant is this memory to it? So they asked LM to judge. So that's I think this might just be embeddings. Yeah, I can't remember it, but they basically these three criteria to retrieve memory. I think those are quite good criteria. And as you can see, this importance score plays a role as well in terms of like how or which memory is retrieved. So I do think that some focus on how we store these memories, like if you store fearful memories as fear, happy as happy memories and so on, you might be able to repeat them. Like let's say you want to, you're in a state where your Pokemon are low HP, you need to escape the cave, then you will just run away from everything. Yeah, so that might be one way to imbue such things. All right, so this is the I'm actually interested to implement out this Pokemon game because I feel like it will be a great test of memory and how we store the memory and how we use them. So I'll be starting an implementation called AgentJo Plays Pokemon. What you saw at the start was just the beginning of the implementation. So in our team, we have a few Dylans, Dylan Cha, Dylan Tan, Nicholas Tan, Nicholas Chen, and me. And if you want to try it out, just let me know. I can provide the API keys for you to do it. So this basically is a game where like we want to give it the input states, the image, and then come out the action. So I tried to experiment quite a bit with image-based memory actually, because I do think that image-based memory is quite important. Like a lot of things in the game cannot be represented as text. All right. Sorry, Evan, you asked something. In the current states, can the algorithm be extended to Gen 2 Pokemon games? I think it can. It's just that we haven't tried it yet because we haven't solved Pokemon Red yet. Yeah, so we start with Red first because that's the current trend. Right. So I actually, back to the slide, I actually want to see whether we can use images as memory because, instead of just storing that text file, why can't we store the images as our past states and then use that when we retrieve past states? Like maybe we retrieve certain things in Mount Moon, I can give you the states that are similar to where you are right now. So you might be able to condition your um, action based on previous similar states you have seen. Why not, right? Why can't we use image as your previous states instead of just using text? And I think that plays a lot with how the brain works also. A lot of kinds of memories are actually visual in nature and not text-based in nature. Like you rarely look at past memories as text, all right? When you remember your past experiences, is usually like some disjointed movie playing back. Yeah, so images play a huge role. Visual memory is very important, right? Because, I mean, there's this saying that, like one image speaks 1,000 words. Actually, it's more than 1,000. You can query this image in multiple ways. You can say, hey, what color are the walls? Hey, where's my people? I mean, where are the people in this image? Or you can say that, what are the texture of this? I mean, this is not relevant for the game, but from micro to macro, if you put everything as text, you're going to lose some information. But if you store your memory as an image, you can still query them later on as that image, and you can get different kinds of answers based on that. And I experimented a bit with like this is map one. Okay, let me use the text. So this is map1.png and this is map2.png. I experimented a bit to see, like, can I just use the LM to describe the image directly and then, describe what happened between the transition of states? Because I want to do something like the DeepQ network paper where you have frame concatenation. So you concatenate the frames together to give the agent an understanding of what happened before. So, in the case whereby in the Mount Moon, we went down the ladder and then when you go up, it went back up north, right? If you can give a stream of past few images before you entered that ladder, and then once you exit that ladder, you can see that, oh, actually I came from the north. Then, that memory might be enough to cue the agent, hey, maybe I should go south. Yeah, you don't really need to store all this in text. You can just, based on your past episodes, you can just store that things in images and you just retrieve the relevant images based on where you are right now. So in this case, it's not just a single image, it's actually a memory stream of maybe 4 images or 2 images. You might be able to bias your actions accordingly to explore things that you have not seen before. So I have a strong feeling the explore exploit in our brains is visual based. So basically, that's for people with vision, right? It's basically saying that if you have done something before and you have seen something familiar, you might want to go somewhere else. All right. So that's why we can get lost in hatch mazes because all of them look the same. But if let's say all your rooms look different, you will know, okay, I've done this room before. Okay, I should go somewhere else. Yeah, so why not we do images in the memory directly instead of text? So that's the question I'm asking myself. And yeah, so far I've experimented with like Gemini Flash. It's not too bad, it's able to say that, hey, there's we are in a cave with 2 other characters, and then the other one's character in the bottom left has disappeared, and the player has moved slightly to the right. And yeah, basically this is Gemini Flash 2.0. I tried Flashlight. I tried that one. Sometimes it works better, sometimes it's not. So it's I guess it's related to the prompting as well. But you can see that it's quite easy to use like strict JSON to do image and text prompting. Just use the double angle brackets and you can wrap your image here. You can also wrap the URL for the image. So I spent some time last week to do this. I think this is quite important for LM agents in the future because we are reaching the stage of multimodality. No longer are we just satisfied using text. We want to also use images. And in the future, audio files, video files, and so on. Yeah, we are getting to that stage already. So this using images as memory is quite important for an agent to understand like the game world, especially since in this case, the game world is an image. All right, it's not a text. So if you convert the image to text, you might lose certain things. So it might be easier to extract the information as images directly rather than compressing them into text. So this is the hypothesis I have. We'll try it out and I'll let you know shortly whether it works. So one thing, this one idea. And also related to this idea, I tried to, give it the actions here, what the actions A, B, up, down, left, right, and then ask it to come up with a list of actions needed. And it's able to tell me, hey, the player is here at 6:20 and the NPC at 7:22, and to go to the NPC, I just need to go down, down, right, and A. So well done, Gemini Flash. Okay, I tried using 4.0. 4.0 didn't really do it that well. The planning had some issues. I think maybe O1 might be able to do it better. But for now, in terms of the most like cost-effective model to do this multimodal stuff, I opted for Gemini Flash 2.0. Yeah, I tried quite a lot of models. So this is the final model I settled on. So this is like how this multimodal thing could be processed. You just give it the image, give it some instructions, and then get it to produce some actions. And if you want to expand it, you can also give it past context here. You can give it past context of similar scenarios, image plus text. You can prompt the LM with that. And now with multimodality in LMs, you can prompt images and text interchangeably. You can just put the image in the middle of text. You can just say, this is an image of a map. Then you put the double angle brackets map.png. Then you close the angle brackets and you can say, use this to navigate. Or these are the past 5 instances of this map. You can just put everything in angle brackets like this. So yeah, in the future, I hope to expand this to videos, audios, and so on. Right now, I only use image because most models can only do image right now. We haven't reached the video and audio yet. Audio is a separate model. It's not very mainstream. So I think this is something that is progress in the LM space, LM agent space. Like we are moving away from just text only. We are going to multimodal right now. And this Pokemon game will be a good first use case of it. Of course, if you want to do harder ones, you have to use 3D worlds. But I think this is something to try it out first. All right. I'm very sure vision models will improve in very, very shortly in the near future. And that's when we are able to do more powerful things. Okay, the next point I have to say is that, we can also use algorithms to navigate. Instead of using the LM to plan and navigate, why not just use some pathfinding algorithms like A-star search? Like if you already have pictures of the map, like you know you are going to start here and you're going to end here. Like one way is to convert this map into some ASCII grid or and then do pathfinding on it. I mean, you can use some form of algorithm to do pathfinding. And this algorithm can even say that, hey, if this area is unexplored, maybe I want to go and explore this area. Yeah, so maybe some logic like this that doesn't really need the LM to make that decision for you might be helpful. Because, as you know, with LMs, you might get stuck doing certain actions. You might not remember the full picture and so on. But if you use certain algorithms can break the loop, right? Because you use rule-based methods to decide what to do. So I think for stuff like navigation, maybe we kind of need some form of algorithms to do it. Using LMs is not that reliable because you can keep doing the same action again and again, or you might forget where the map is, right? So another way is like, maybe if let's say you have a way to map this grid map into nodes and edges, I mean, one way is to do A star search. The other way you can do like breadth search, depth search, Dijkstra, Floyd Warshall. This kind of methods can also be used to do navigation. Although I do think that, just a simple A star search or just, I think A star search might be enough. Yeah. So this basically, the 2 points are saying that one is image-based navigation. Okay, image-based, of course, you can't do like A star. Maybe image-based is just using the LM. The other one is convert image to like grid and use pathfinding algorithms. Yeah. So I think there are two different ways to do this. Just use whatever way that works better. I have to experiment a bit on this too. Another way I was thinking of is that, if let's say you are not that great, LMs may not be great at planning like 20 steps, but maybe they are good at planning 3 to 4 steps. You can use hierarchical planning. So hierarchical navigation is like this. Instead of going like square by square, I can say that broad planner could say that, okay, Mount Moon first floor, ladder at 2218, and then you go to Mount Moon B1F, basement 1, and you go to ladder at 415. These numbers are all made up, all right? I'm just giving you an example. And then maybe Mount Moon basement 2, and then the coordinates is like this. So maybe your first planner could, based on the overall like ladder positions, give you all the transitions for the ladders. And your next planner would then, from first floor to basement 1F, from first floor entrance maybe to this coordinates up, 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 and so on. So basically, like it does planning based on that starting coordinates and ending coordinates for each floor. So this one is inter-floor navigation, and this one is within floor navigation. You can do the same thing for like inter-map regions in the world map and so on. There are different ways to do navigation, like from broad to narrow. And if you do navigation like that, maybe you don't need pathfinding algos. Maybe you can just use an LM to do it. I don't know. I'm just taking this idea out here to explore. All right. So we perhaps could do everything with some form of LMs plus some form of simulation. That's enough. We may not need A-star search, Dijkstra, Floyd Warshall, all this. Yeah. Because certainly I don't think we have such algorithms in the brain as well. It may be related, but it's not the same. Yeah. So I think there are different ways to navigate, but what I'm very sure is that just using LLMs alone with text to navigate is problematic, all right? Because the game world is not in text. The game world is in the grid. Maybe you can store the game world as a 2D grid in text. Maybe that will work. But I do think you still need some form of pathfinding algo in order to help the planning of the LM. Like, I'm not too sure whether, given like stuff like this, it can map nicely to the actions. I'm not very sure about that. Okay, yep. And that's it for this part. Anything to add for this? Okay. So yeah, actually I've reached the end for today. Let's talk about some questions to ponder. And yeah, I'm just going to say some of my thoughts about this, and then I invite you all to share your perspective as well. So the first question is like, how much of an agent's performance is due to the LM itself, and how much of it is due to the external structures like tools and memory? And I'm just going to say like, I think maybe it's only 20% LM and 80% tools, because like LM is pattern matching, but without the tools, you cannot pattern match properly. You need to have the pattern match be done, must be done in the same abstraction space as the action space. Yeah, and as the action space and the text space. So if you don't have the tools to go through different abstraction spaces like broad to narrow navigation and so on, that you may not be able to use LMs very well for doing things. Like your tools need to be the reply needs to be of a form that the LM understands in that space. Like if you are talking about the navigation tool, your tool needs to reply, hi, you have navigated to this square, 2218. Yeah, it shouldn't be, the tool shouldn't reply, up, right, left, right, because it's the different space in terms of abstraction. You should talk about things that like in terms of coordinates where the agent already is aware because of the RAM state. Yeah, so I would say that tools are very important. If you give it the wrong tools, it will never solve the problem. Yeah, so in fact, games like this, while people try to do like AGI to do everything, I would say that actually AGI may not be desirable because, you know, some things are better solved with simple tools. Like I actually wanted to cover this paper. Maybe I'll cover it next time. This is called agentic reasoning. Basically they only have two tools, Python code tool and web search. Just these two tools, they can solve a lot of things already. And I mean that's amazing because you don't have to have specialized tools. But you know, if you are doing a problem that needs no coding, you can actually have a fixed function to do it. Like for example, you know, color and image. Yeah, you can have an image coloring function. You don't have to code it out. Yeah, because like using tools like coding may incur errors. And you know, maybe you can say that, yeah, maybe something like this might be AGI, but you know, when you're doing a certain process, you know, you may not really want such dynamic coding tools to be used. You already have a known tool that works very well. Just do this. I mean, like, I think like this whole hype to go towards AGI might be useful for problems you don't really know the answer to. But if you already know, like, hey, this domain should use this kind of tools, then should just do something that is extremely domain specific. Domain specific plus optimize, right? And this one is a bit more general plus not optimized. Yeah, so it depends on what you want to do. I think for like playing the Pokemon game, we don't exactly need a very general agent for it. We need an agent that understands how to navigate, understands how to do the menu passing, and yeah, it can also understands like what um at what process is the agent at. Like, are we fighting Team Rocket now? Are we okay? Which batch have we not collected? You know, you need to have agents that can actually interpret the game information and come out with your next plan and next goal. Yeah. So those kind of things, you know, your prompts might need to say that, hey, your goal is to collect the 8 badges. I cannot just say your goal is to win the game, right? Because I don't think the game really has a way to tell you, hey, you need to win the game by collecting the badges. Okay, maybe it has, but no, it's not going to be easy for an LM to decipher it by itself. Like if you have a general agent that says that your goal is to assist the user, right? But in this game world, you know, what's assisting the user? Like so, uh, out there at one spectrum is AGI to do everything, but it might also do everything badly. And the other spectrum is very specialized domains, specific tools and processes that can get the job done. And so far, I'm actually more in favor towards the more domain specific ones because I really don't think that the general case is like, I mean, it might be useful to help you to understand how to first solve the problem. But after you know how to first solve it, you should just go to the domain specific ones. It's a bit more optimized and faster. Yeah, sorry, I see some text. Let me take a look. Evan, you asked, let me see who's, give me a moment. Let me scroll. Seon asks, kind of feels like when Claude finally decided to explore south in the cave, it's probably because it was thinking very out of the norm, high temperature. Yeah, I think so. Yeah. I think that might be one of the reasons why, and also maybe because of the context wiping out in some cases, and uh, just a combination of factors led it to explore south. Yeah, I cannot say for certain why because it's an LM model, but yeah, there are different combinations of factors. Yeah, and that's why I say that using LMs to do like exploration, you might get stuck, like what you see in Mount Moon for Claude Plays Pokemon. You might need an external structure that, you know, is not like pattern matching based. It's more like based on what have you explored and what have you not, prioritize certain things. Yeah, so I think something like that might be needed because LMs are great to do pattern matching when, you know, you know for sure, okay, this context is relevant to what the LM needs to process certain things and output, like maybe a one-step output. LMs do very well for that. But if you're talking about long-term planning, I don't think LMs are very good for long-term planning. Yeah. So even with the thinking models, LMs are still not very good for long-term planning. Yeah, it's just a different, like how I say it. I do think that using just text alone for planning, like some people say that DeepSeek, DeepSeek is able to multiply 6-digit numbers by 6-digit numbers without using calculator. They basically just reason the entire steps out themselves and add it up, which is pretty remarkable. But what I'm saying is that, like, why are we using text for math, right? Text isn't the natural representation for math problems like this. It's still, you need to go through the multiplication, you need to follow the rules and so on. So these domains are actually very rule-based. Math is very rule-based. Why are we using LMs for math? Yeah, and like how can you be so sure that your training set is not contaminated with the answers already? Yeah, so I don't really agree with how the LMO is developing right now because I don't think an LM will solve everything. So that's my opinion. I do think that LMs are useful to do pattern matching in free text, in natural text. They are just not that great to do it for rule-based things. But one exception is you ask an LM to generate a code, a Python code, and then execute the code. So I consider this neuro-symbolic because you use the LM to give some form of structure in terms of how to solve the problem, which LMs can do quite well because it's trained very extensively in code. Then you run the code to do your answer. Yeah, I think this works quite well if you have a human in the loop to just verify that the code is correct. Yeah, so this I think is still acceptable. But using LMs to try to solve like 6-digit by 6-digit without any tools, I think that's just, barking up the wrong tree. Yeah, we are trying to solve problems that shouldn't be solved by LMs using LMs, right? So at least this is my perspective. Right. Any other thoughts for this first question before we move on to the next one?
I do agree with the idea of tool and memory use for the LLM, but I think at the higher level, before you start accessing the external tools and memory, I think before that, I think you need a structure for task and like really like idea and or abstraction decomposition. But really the idea, the the algorithm of decomposition. Just because if you notice in the earlier slides, the big issue with the LLM is context, memory. That's very forgetful because you're giving the LLM this entire universe of information in like one single prompt. If I as a human being get told like 2,000 words and I'm expected to do miracles off of it, my brain's just gonna explode. Like I'm not doing it. That's not how I work. What I do is I use reasoning algorithms in my mind. I decompose the task or the issue, the problem, and I decompose into simpler and simpler issues or subtasks that can be solved quickly by pattern matching. And the whole point of a neural network, a language model in this context, is pattern matching. It is input to output. So the best way to utilize the LLM in this pipeline is you want to do what it's good at, which is pattern matching. So you have it, you create these, you could create these architectures, these kind of symbolic pipelines of decomposition, but you use the individual nodes as prompts. So you can have the LLM take a big problem, an abstract problem, and have it decompose it into subtasks or into sub abstraction spaces. So if you have the LLM just focus on decomposing one at a time, you'll have a bunch of subgroups that are much simpler to pattern match. Like say pattern match a subnode into tool use. If the subtask is derived from several iterations of decomposition, the subtask should, in theory, be a very simple idea or a very simple problem or task. and the LLM can then be prompted to take that node, that very, very simple subtask, and do a very simple pattern match to a tool or to a very specific memory file, right? Because that's your idea, right? Is to try to create very precise context dependent memory files that you can use that are very context dependent and very adaptive. But you can't have adaptive without a certain level of precision and relevance, or I should say relevance precision, really, right? Because if you're off on your mark, you're not going to access the right information and you're not going to have any useful info or any useful output. So if you're able to focus heavily on decomposition, which is something I'm trying to work on, I again, I ask for forgiveness. I've been very busy. I'm behind on my project, but I am trying to build on my idea of like decomposition and hierarchical task networks. The idea that if you just decompose something enough, you can then do direct pattern matching and direct triggering even of other tools and other memories to access. And you kind of reduce the context and the other issues, the context and the memory issues of the LLM almost completely because you're solely using the LLM for its sole purpose, which is pattern matching. You don't concern the LLM with context size or with memory issues. You just focus the LLM purely on what it's good at, which is going to be pattern matching. Everything else is going to be symbolic. Memory is going to be symbolic, knowledge graphs, image compressions, concatenations, whatever. Tool use, everything's going to be symbolic. So you have no consistency issues. You purely focus the LLM on that pattern matching. I think you'll solve a lot of problems because of that, in my opinion.
I mean, there's one take on it. Like, I mean, you split your problem into subtasks using LMs. But what if your problem is so complex that the LM cannot split properly? Then, like for example, navigation across multiple levels. Maybe one way to solve it is just to use a fixed rule parser to, do some pathfinding. Like you don't really need to split the problem into saying that, hey, I should first find a way to get from first floor to basement one floor, then basement one floor to basement two floor. Yeah, I mean,
No,
sure you
no,
can use,
yeah,
yeah.
no, yeah, I get your point, but no, that my argument, that is part of my argument, is that it's before you get into Dijkstra algorithms, right? You do your decomposition of your current goal, right? And then you do your goal decomposition into subtasks and into sub goals. Then those sub decompositions trigger the tools, right? So you can reprompt the LM, right? Like here's a new environment, here's your goal, decompose, do your decomposition algorithm based on the LLM prompts. And then the LLM will be like, oh, in this context, I have this subtask. Let me use the Dijkstra algorithm, right? And I can retrieve the memory file. I can retrieve the screenshot. I do a quick Dijkstra on it, right? I reduce it, and then I find the shortest path to my goal based on the screenshot, and I just trigger the function run or trigger the navigation tool. Boom, done. Right. So it's before your tool use, before your memory access. You want to do your decompositions first, and then use your primitives for your problem solving, for your symbolic use, for your memory and your tool use, including pathfinding, including memory access and memory retrieval. That's my argument.
I get it. So basically, what you're saying that LM should do some decomposition, but actually this decomposition can be done at many levels. You can actually decompose your subtasks into sub-subtasks and so on. And then once you reach the level where your tools match the input space, then use tools. I think that's what you're saying, and I agree with this. Yeah.
Exactly. It's all about pattern matching. If the LLM trains on the entire data of the internet and the only thing it's good at is pattern matching because of the attention mechanism, fine. We're just going to use the LLM for decomposition and just for pattern matching. But we're going to do it intelligently. We're going to pattern match into different levels of abstraction and subtasks and what do you call it? Subnodes into primitives. We're going to just decompose into primitives and do pure pattern matching from a start goal to an endpoint and use that to trigger our tool use.
Yeah, I agree. So I think this is a matter of how the LM is used in an agentic structure whereby you do some subtask decomposition. And I do think that this is something that is important in terms of performance. Like you you give an LM a very complicated task, like even if you do like the thinking models and so on, it can be difficult to get an answer compared to you splitting into subtasks already and pass it to the thinking model. And yeah, I do think that this is something that it can be explored. Like, I mean, AgentJo already does like subtask decomposition. It's more like I feel like if you don't even have the proper tool to navigate, like even if you decompose to the smallest task, you might not navigate properly. So this is again a matter of tool use matching the input space. And I would say that as much as decomposition works, the tool use actually is very important as well. Actually, everything is important. So like giving like the earlier graph where we showed that Claude 3.7 Sonnet plays Pokemon better than the rest, like that's subject to agentic structure, tool use, memory, and so on. Like the LM itself, no, maybe the LM can do better because the context is longer, but I would say that just purely based on an LM to play the game more, like that's actually not the right focus. I think the right focus would be more of like how the LM is structured in the entire chain of decision making. Like that structure itself, I think is very important. And like sure, you have a LM that can think better, but there's just some limits to how it can do it without the right structure. Yeah, so I would say that is mainly the structure than the LM itself. So yeah, still stick to my 80% structure and 20% LM theory. Uh, okay, so let's move on. Should emotions be used for memory retrieval and storage? I would say yes, okay, because emotions can help to prioritize what is important. In fact, using the event boundary, you can get context dependent memory, which is useful also because you can then store your memory in the right reference frame that can be retrieved again in the right reference frame. And yeah, this one is all quite important. The only thing is that if we use emotions, but the caveat is if emotions, like for example, fear, might prevent exploring that memory again. Yeah, so there's some caveats to this. I do think that emotions are needed to do some filtering of the search space. And this might be useful to help to like streamline the agent's performance. But as I said, you might streamline too much. So what we really need is we need different agents with different experiences so you can explore more. Like just one agent itself, you might get stuck. Maybe plot agent number one might get stuck at Mount Moon ladder, but the second agent might, see that cloud now agent one is that at that ladder, maybe it decides to go to the next ladder instead. Yeah, so like this is something related to like AlphaGo also. In AlphaGo, in the Monte Carlo tree search, basically they did a simulated Monte Carlo tree search in the sense that if one agent is exploring that node will have a huge negative value, and other agents will explore other nodes. Okay, of course they didn't call it agents back then in the paper. It wasn't called agents. It was more like threads. Right? If one thread explores one node, then you do something else. So something like this, like you can have multiple agents explore the same world at the same time, and then if let's say someone has explored something before, as a group, you will do something else. So like I do think some form of like filtered search space based on certain triggers or stimuli of the environment encoded into some heuristics like emotions will be helpful to streamline the agent's action space. But I do think this needs to be coupled with multi-agent structures. If not, you might just lose the correct answer if you just streamline it too much. Yeah, so that's why it's very important in human society. There are some people that are not scared of things. Okay, if not, we will never try everything, is it? So this is a fact of life, I guess. Like you do need more than one person. And I think that's coming soon. Like this year should be the year of multi-agents as well. This year and next year. Very exciting work and development is coming up. And I'm actually very excited for all this. But I still think emotions are needed because if you just take a look at the way that we retrieve and update our information, we don't really have a very good way of of remembering things because everything is given the same weightage right now in the Claude Plays Pokemon. You need to have certain things that are given more weightage, and that's when some heuristics like emotions can help. And also based on certain surprisal emotions or like based on location transitions, you can encode new memories based on this event boundary. And this will really help a lot with the storage of the right information. Okay, I'll move on to the next one. Feel free to interrupt me if you have anything else to add. Next, can we interpret images without the need to convert to text? I'll say yes. In fact, it may be better because you can have more info when you query the image later. Like if you just change it to text right now, based on different contexts, you might get different info that you store in memory as text, but you lose the original image. But if you can keep the image, you can use that for future different tasks based on different contexts. Yeah. All right, so the last question, what other forms of memory should we have? Maybe one way is to have, I think text is still important. Text is one, image, memory, maybe knowledge graphs, maybe, abstraction spaces of the above. So like sometimes you want to store like things that are a bit more condensed, sometimes a bit more micro, sometimes a bit more macro. It really depends on where, what you want to do with that information. So different abstraction spaces needs to be there as well. Yeah, I think that's really it's just about like one memory for each modality you have, right? And then like you can do some form of mix and match, and basically you can have a mixture of agents. Each agent involved in one modality, they can communicate with one another and come up with some consensus that could be done. Yeah, actually those are very advanced ideas, but I think these kind of ideas are very feasible in the near future. All right, that's more or less it for today. Any other thoughts that you have or any insights you have from this Claude Plays Pokemon? I know this is a game thing and it may not be very industry related, but I can assure you that if you can solve this game, you can solve quite a lot of industry related problems with agents, right? Because like right now, people are trying to use agents for automating workflows and everything. Adaptiveness is a very important thing. And one key thing to adaptiveness is memory, how we store and retrieve memory. Of course, the other way for adaptiveness is fine-tuning. Okay, which is not covered today because fine-tuning in general, you need a huge amount of corpus of data and then you fine-tune it. And after you fine-tune it, you might be too specific to your use case. So fine-tuning is important if we only want to do that use case, right? But if not, how we store and retrieve information by external memory, I think that's very important. Okay, maybe I just wait 5 seconds or something. Any other things to bring up for today? Okay, if not, just do some quick promo for the just 1 minute for the AgentJo logo design competition. So it will end tomorrow. So currently these are the three finalists. About those three Pravan, he came up with a very friendly looking AgentJo logo with three alphabets. I quite like this. Randy is a bit, his brother came out with something a bit more professional. So this one, if they win, they will likely convert this to using a software to make it look nicer. And then Neon Ice nephew did one that I quite like, this infinity sign thing. So do vote for your favorite one. You can go to the Discord group to vote. It's under the Agent Joe logo channel. And yeah, the winning one will be used as the logo for Agent Joe. So yeah, just some promo. And yeah, with that, I think today the Claude Plays Pokemon is quite an interesting thing to let me go back to the screen here. I think this is a very interesting project. It shows like how we can use some form of tool use and like image and memory processing to play a game. And I think this is just the first stage of it. It could do with a lot more work in terms of like the different memory modalities, in terms of how we prioritize memories, how we improve the tools. There's a lot of things that can be done to improve this. But I think overall, this is the first step to real life interaction and learning for agents, which I'm very excited to work on and also to cover on for the next few years. All right, with that, signing out. Thanks for coming. Okay, bye.